Hello everyone. This is the third lecture of engineering geology. In the previous two lectures we discussed the introduction part of this subject. In this lecture we will discuss the what is the role of the agencies like wind, glaciers or rivers or some other agencies in transforming the landform features of. First of all, we will start with the geological work of the wind. As we know, that atmosphere is composed mainly of the gases that are collectively known as air. When this air is set in motion, it's called as wind. Wind is actually one of the three major agents of the change of the surface of the earth. Other two rivers, as I have already mentioned, are rivers and glaciers. The origin, movement, and classification of winds are all meteorological, mainly due to the non uniform heating of the surface of the earth at different places, causing differences in the atmospheric pressure. This pressure difference so created makes atmospheric gases to move from areas of high pressure to the areas of low pressure in the form of winds. This wind has the second type is wind abrasion. As we know, abrasion is when the two bodies are rubbed against each other. That's known as abrasion. Wind becomes a powerful agent for rubbing and abrading the rock surface when naturally loaded with sand and dust particles. This load is acquired by the strong winds quite easily when blowing over sand dunes in deserts and over the dry plough fields. This type of erosion involving rubbing, grinding, abrading and polishing the rock surface by any natural agent, wind, water or ice, with the help of its load while passing over the rock is termed as abrasion. It's one of the most common processes of erosion of rocks in nature. Wind abrasion is responsible for numerous features of erosion on the land surface, especially in the arid areas. Yardings, pedestal rocks, vent facts, and desert pavements. The sand grains and other particles lifted by the winds from different places are carried away to considerable distance. During this journey, the particles are not moved in straight lines for the simple reason that all particles are not of the same weight and the wind velocity also varies from base to the top of the current. The grains are therefore moved in a zigzag fashion, colliding with one another again and again. These repeated collisions cause lot of mutual rubbing due to impacts. The wear and tear of load sediments suffered by them due to mutual impacts during transport process is observed in wind as well as rivers. It's termed as attrition and is primarily responsible for reduction in the size of the load particles. That means these particles, a large particle, because of attrition, gets changed into smaller particles. The intensity of the wind erosion by the discussed processes, that is by wind abrasion, wind attrition, and by and what we call as deflation. The intensity of wind erosion by these processes actually it depends upon the three main factors. One is nature of the region. Areas covered with thick vegetation or grasslands and forests and those made up of mostly of hard and sound rocks are least affected by wind erosion. Velocity of the wind is another factor. Winds seldom blow in the same direction in an area for all the time in a year. In every region, however, there is a prevailing direction in which the winds often blow repeatedly for a larger part of the year and with higher velocities. Rocks lying along the high velocity winds are eroded more and faster compared to those where winds change velocity frequently and also blow with lower velocities. Duration. Erosion and other geological processes are by and large slow and steady in nature. This simply means that their effects become noticeable only after sufficient time has been available to geological agent to act on the land surface. The same fact is true for wind erosion also. The longer the duration of erosion, the more pronounced are the features developed. Sediment transport by the wind is an important aspect of the geological work of wind and needs to be discussed under the three specific heads. First is source of sediments, second one is method of transport, third one is transporting power of the wind. Wind is an active agent of sediment transport in nature. Material of fine particles size such as clay, silt and sand occurring on the surface of the earth are transported in huge volumes, thousands of tons a day, from one place to another in different regions of the world. A great part of the wind load is contributed by the dry, incoherent regions like sand, deserts, and freshly plowed fields. Some load is also acquired by the wind itself from its abrasive action over the surface of the rocks. Second one is methods of transport. The wind transports its load mainly by two distinctly different processes. First one is suspension, second one is saltation. The light density clay and silt particles may be lifted by the wind from the ground and carried up high up to the upper layers of the wind where these move along with the winds. This transportation is called suspension. Because the particles once lifted are not allowed to rest on the ground again till the velocity of the wind in those upper regions is checked considerably, as by the intervention of rain or snow, or slow down due to the distance involved. Second one is saltation. The heavier and coarse sediments such as sand grains, pebbles and gravels, etc. are lifted up periodically during high velocity times and only for short distances, and that too for smaller heights. That means this process is very short process, that it remains for a very small time. Their movement takes place close to the surface, generally up to 2 meters. They may be dropped and picked up again and again during the transport process from one place to another. The height and distance to which these sediments are transported in one cycle depends on the size and shape of the grains, the density of the material making the grain, the velocity of the wind, and also on the nature of the surface of the ground over which the winds are blowing. In the typical saltation process, each particle suffers a fall after reaching a maximum height in one cycle of lift and drop. On falling, the same particle transmits an impact to another stationary particle resting on the ground, thereby making that particle to be available for transport. Saltation is therefore a process of sediment transport in series of jumps. Still, heavier materials and even boulders of odd shapes and size may not be actually lifted up. Even this type of load may still be transported over short distance by strong winds through rolling, skidding, and sliding motion along the ground. This type of sediment transport by winds is also included under saltation. On the slopes of the heaps of loose material, as in sand dunes, the displacement of particles is delicately balanced at angle of repose. Winds may induce down slope displacement, literally a transport through short distances by their velocity. This displacement is sometimes specially referred as creep. The third one is the transporting power of the wind. The transporting power of the wind depends on the velocity as also on the size, shape, and density of the particles. The amount of load already present in the wind at any given point of time will also determine its capacity to take up the further load from an area that happens to lie in its course. Thus, at that point of time, the wind may be underloaded, fully loaded, or overloaded, depending upon the carrying capacity of the wind. Obviously, the carrying capacity of wind for taking up any further load from new areas in the last two cases is very limited. In fact, overloaded winds will rather drop some of their loads while moving ahead at the very first opportunity becoming available. The sediments and particles once picked up by the wind from any source of the surface are carried forward for varying distances depending on the carrying capacity of the wind. Whenever and wherever the velocity of the wind suffers a check for one reason or another, a part or whole of the wind load is deposited at that place. Factors that commonly result in a check in the velocity of the wind include prominent obstruction such as hills, mountains, forest belts, and also precipitation, that's rainfall or snowfall. Load dropped by wind in particular region may be a very small or of considerable volume. These wind made deposits may ultimately take the shape of the landforms that are commonly referred to as aeolian deposits. These are of mainly two types. One is dunes, another is lows. Dunes dunes there are variously shaped deposits of sand grade particles accumulated by winds. A typical sand dune is defined as a broadly conical heap of sand characterized with two slopes on either side of the medial ridge or crust. A dune is normally developed when a sand laden wind comes across some obstruction, a small bush or raised surface, or even a pre existing sand heap. The obstruction causes some check in the velocity of the wind, which is compelled to drop some load, that is, sand particles, along, against, or over the obstruction. When this process is continued for a long time, the accumulating sand takes the shape of mound or a ridge, meeting the definition of the dune. In fact, once begun, the dune sand themselves acts as an obstruction, helping further growth of the dunes. Second is loose. The term loose is used for wind-blown deposits of silt and clay-grade particles. Typically, loose is unconsolidated, unstratified, and porous accumulation of particles of size range 0.01 to 0.05 mm in diameter. This size fraction makes almost 40% of a particular loose deposit's rest being made up of the still finer clay grade material. The loose deposits are considered most widespread examples of aeolian deposits. They occur in North China, North America, and Europe. Although there are different views regarding the origin and formation of loose, it is accepted by all that wind plays a very prominent role in their origin. Strong winds blowing over very extensive area of deserts, outwash plains, and soil loosened by ploughing pick up vast amounts of fine-grained particles for transportation in suspension. When such dust-laden winds passing over the steeps and other flat surfaces are intercepted by precipitation, they drop their entire load on the surface below. This process is repeated year after year. Accumulation of such sediment